Reflecting on that last test, so the test of my telekinetic powers, you probably noticed that there is an issue with the way we evaluated the strength of the evidence. Most people, in my experience, become convinced that I have telekinetic powers around the fourth coin toss, so let's say it's about here. That's the cutoff line, somewhere between the fourth and the fifth. That seems fair. Most people don't become convinced that I have telekinetic powers until about the third of the die rolls, or the dice rolls. And that is inconsistent. I'll show you why that's inconsistent. To get a fair heads in a coin toss, the odds are 1 out of 2. To get 2 in a row, it's 1 out of 4, 3 in a row, 1 out of 8, 4 in a row, 1 out of 16, 5 in a row, 1 out of 32. Which means that most people are convinced that I have some kind of powers somewhere between 1 out of 16 and 1 out of 32. Those are the odds that they find convincing. Now let's look at the rolls of the dice. To get 1/6 is 1 out of 6. To get 2 in a row becomes 1 out of 36. So we have already done something slightly rarer than that, slightly more unusual than this one. These odds are lower than those odds, and yet most people would find this more convincing than that. This is a problem of consistency, that when we change the method by which we evaluate the claim, we also change our standards, making it harder to demonstrate telekinetic powers with the dice than it is with the coins. And that's a problem. If we want to make this fair, we need to find a way to systematically even out the standard at which we will accept evidence. How rare would something have to be for you to decide that it was an interesting event, an event worth paying attention to or being convinced by? In the interests of being fair, at some point you will have to draw a line and say this is where the cutoff point is. This is how rare or how unusual or how unlikely an event has to be before I'll start paying attention. Psychologists have decided that the cutoff point for us is 1 out of 20. If something is rarer, or if an event shouldn't happen more than 1 in 20 times by chance, assuming the null hypothesis is true, then we pay attention to it. We become convinced by it, at least to some extent, and we call that significant. If something is bigger than 1 in 20, so in this case if it's 1 out of 2, or if it's 1 out of 4, then it doesn't count, and we call that not significant. If you understand why we need to evaluate evidence, and if you understand why we need a fair standard through which we can evaluate this evidence, and if you can see why 1 in 20 is kind of an okay cutoff point, then you understand what the critical value is for an experiment.